Okay, so erythropoietin is released. It tells the red bone marrow to make its blood. And then you have, in the red bone marrow, you have reticulocytes. What they are is they're like baby red blood cells. They're not erythrocytes just yet. So they're immature erythrocytes, and we call them reticulocytes. And they're just running around in the red bone marrow, waiting to get the signal to grow up. So once they get that signal from erythropoietin in 1 to 2 days, they will grow up and they'll go out into the blood. So now we have more red blood cells to carry more oxygen. And why this is a negative feedback mechanism is because oxygen levels are down. We do the total opposite by increasing oxygen levels. We shut it off. We say no more erythropoietin, we have enough. You will see some things happen, some cool things happen with like altitude sickness. When you go up into a high altitude, what happens as far as oxygen? Because what do they say about the air? They say it's thin. That's not a true depiction of what is going on with the air up at 12,000 feet, Colorado. It's still the same air. The problem is when we're down here lower at, a little above sea level. I can't remember what Muskogee was at, but it was like 3,000 feet above sea level. I mean, we're pretty low. So there's a lot of gravitation. There's a lot of pressure. So down here, the oxygen molecules are closer together. So we get a lot in. Every breath, I can suck in a lot of oxygen. Whereas if I go 12,000 feet, the oxygen molecules don't have so much pressure on them, so they're spread way out. And that's why they say it's thin. Still the same air. It's not really particularly thin. It's just they're way spread out, so we're not getting in as much oxygen as we would down here. And we're not used to that. We're not used to those levels being a little lower. So what will happen is our kidneys will send out erythropoietin, but we'll send out red blood cells quickly. It won't take 1 to 2 days. We will send out immature reticulocytes. We'll send out baby red blood cells and put them to work before they're ready. And so you get a large amount of blood. Your blood volumes are higher. And that's another reason why athletes, your really hot elite athletes, will train in Colorado. They'll go to high altitudes and train, like your bikers and things, because they get used to those lower oxygen levels, training at that. And you'll notice if you have altitude sickness, anywhere from 1 to 2 days, you feel better. Because you've now made more red blood cells, because it takes 1 to 2 days to make them. And you feel all better, because now you've got plenty of oxygen. It's kind of cool what happens. You do need to know a life cycle of a red blood cell. Red blood cells live, and this is very important for nursing, they live 120 days. Well, why is that important? Well, that's important because there is some lab values that we'll look at. So one is red blood cells also will have sugar attached to them. And so after 120 days, we'll draw a lab value, which is called an A1C. It's a hemoglobin A1C. And we can draw that lab value, and we can look at a patient's A1C and see how much sugar or glucose they have in their blood. And say it's a 7. We don't usually like them 7 and above. But if it's a 7, that tells us for the last 120 days or 3 months, that patient's been kind of running high on their sugar. Unlike me doing a fasting blood glucose or just sticking and pricking your finger, I know what your sugar is at this point in time. I know what your sugar is at 10:05. It didn't really do much for me over a long period. I want to know what you've been doing and how your sugars look for 3 months. And that's because of these red blood cells living for 120 days or 3 months can tell me that your sugar has been running high for the last 3 months. And that's why you'll see your diabetics will go in like every 6 months. They'll start out every 3 months, and then they'll start going every 6 months and getting their blood drawn. And it's a hemoglobin A1C that they're actually drawing. So that's kind of cool. And and why we draw those lab values. Okay, let's look at a life cycle of a red blood cell, that negative feedback mechanism, what's going on with it.